Okay, now the next topic we're going to go through is the idea of moving money through time, which is a very practical exercise in economics accounting. For this one, we have broken up the screen into a couple of different areas. We're mostly going to be drawing on the left side, but on the right side, I want you to watch over here because I'm going to be going through some steps in a few minutes. So first of all, let me just kind of go through a basic understanding. It's often we're going to have to move money from today and estimate what it'd be valuable, what it would be worth in the future. And in that case, the first step we would do draw a cash flow diagram. So let's say we have some money that is today, we call that P. And then let's say in 10 years, we want to know how much would it be. So we have the P, we want to know what the F is. The F is the unknown. And if we know how many years, which is the N or number of payments, if we know how long we have the money, and if we know the percent interest rate, we often call that I, then we can estimate the F value. And the nomenclature for this, which is often used in economic accounting, is say if we have the thing we want to find is on the left, we have this slash, which is not a division sign, it's just a nomenclature. So we say F is what we want to know. We are given P, which is the initial amount, and we are given the I, which is the interest rate, and we are given the N. Okay, and in this scenario, if we know those things, if we know P, I, and N, we can always calculate F. Okay, and that's one of the things we'll be doing in a few minutes. Similarly, we could reverse this around and say that we have maybe a certain retirement goal. We want to retire with $1 million, and we need to know how much we need to put away today if we want to retire with $1 million. And we would just substitute these two things. In this case, we know the F and we want to find the P. And so that's kind of the nomenclature there, and we'll be going through that in a couple of minutes. So over to the right side of the screen, it says the steps. So the first step, whatever you do whenever you see a problem, is draw out the cash flow diagram. That's what CFD means, is cash flow diagram. Now, let's look at another example. Let's assume we have a problem, much like an energy savings problem, where we might have a project that is yielding, say, $1,000 a year, every year, exactly the same amount, even though I'm not drawing perfect arrows here. Every one of these arrows is $1,000. If it's the same every year, $1,000, $1,000, $1,000, a shorthand notation for this is to just not write the 1,000 and just say A, meaning annual value, is 1,000. And that means that each one of these arrows represents $1,000. And again, if we knew the percent interest and if we knew the N, we could proceed in solving this problem. And so in this case, what we want to do is we want to say, hey, if I'm going to make $1,000 in savings, what would the value of that be in today's dollars? In other words, what would the P or P positive be? So in this case, we don't know the P positive. Our nomenclature would be find P given A, I, and N. So as you probably have guessed, the steps for this, the first step is to draw the cash flow diagram. The second step is to label the cash flow diagram. And so basically, what we just did there is we said, hey, what do we have? We had A, we have I, and we have N. I didn't tell you the I, but let's just say it was 10%. Once we have these things, A, I, and N, we can find the P. Now, how do we do that? How do we convert that money over from being an A to a P? And that's what I'm going to show you next. We need something that you can download, and these are, as a very short way of doing it, is called table manipulation or getting table factors. And in these types of scenarios, we're going to go to these tables, which in every case, we're going to be multiplying the table factor by the money that we're trying to move. Let's go to the tables and take a look. So in this scenario, we have $1,000 is what we know. We're getting every year for 4 years, okay, N is 4. Our interest is 10%, okay? So we have the three things, and we're going to go look for this nomenclature. Now, the first step in tables is to get on the right table. So if you look in the upper left-hand corner, this is the key that tells you what percent. So we know we want to be on 10%. Going down the page this way is the N, the number of years. And all of these columns here represent different labels, and it's somewhat your guide into doing these types of problems. This is where you're going to find the right factor. So in the problem we just had, the interest rate was 10%, the N was 4, and we were trying to find P given A. So the table factor, we'd be going over to the P given A column, we would come down to the year 4, we go across the row, and this would be our table factor right here. We're going to take this number and multiply it by the money we're trying to move through time. So now we're back to the to the calculation, and we went to the tables, and we found that the table factor for this find P given A is 3.17. I'm rounding up just slightly. And I mentioned that we're always going to multiply the table factor by the money we're trying to move through time. In this case, we're trying to move this $1,000, which is happening 4 times over 4 years. Basically, we're trying to move this through time to figure out what this P positive is, okay? And so we have 3.17 times $1,000, $3,170. Now I'm rounding up again, but basically what that's saying is that this P positive is worth $3,170. Even though we got 4 independent cash flows of $1,000, you'd think, oh, that's $4,000. But because we have to discount according to 10% per year, that $4,000, when you move it back in time, is only worth $3,170. And another way that this is useful is you can say, look, I know that if the P positive is $3,170, that I know I cannot spend more than $3,170. Otherwise, I'm going to have a negative NPV. Okay, just to wrap things up, we can apply these 3 steps right here to practically any problem where we're trying to move money through time, whether we're trying to determine, hey, I've got this present value and I want to find out what the future value would look like, or vice versa. Let's say I want to retire and I know how much money I need, and I'm going to try to find P. Either one of these 2 scenarios you can do. More commonly in energy management, you have this scenario where you have an equal sum of savings or an estimated equal sum annual value that's the same, and you're trying to move this back to find the present value, and you're comparing that P positive against the cost of the project. Another scenario that you could have is, let's say the savings are not equal every year. Say some years you have more savings than the other years, and other years you have less, or maybe it's escalating. There are other types of ways you can do that, but you could also call this F1, F2, F3, and you could move each one of these individually back to figure out the present value contribution of each one of these. So there's a lot of different ways you can do this. I'm just trying to show you basically that's how you move money through time using the table method. It's very easy. I hope you enjoyed it. We'll catch you on the next one.